Hello, what's up guys? Welcome to Young Minds versus Physics. As usual, let's make the day a good day with us. Right, we are moving on to a very important state of learning. We are done with the concepts of Coulomb's inverse square law and electric field. Right, with the discrete and continuous distribution of charges. That is done. Now we are at that critical position where how to revise the whole concept and bring it into a small set of problems, and how to score more or maximum marks from the topic. Right? So, if you have not done these problems, it means you are not ready for your exam. So, such important problems, right? We are going with those problems, and the first one from that set is: a copper atom consists of nucleus surrounded by 29 electrons. So, how many electrons? You know that copper has 29 electrons. Like, atomic weight of this is 63.5 gram per mole. Let us now take two pieces of copper. So, he is giving you the atomic weight and two pieces of copper. Like, each weighing 10 gram. Right? Weight of the copper is also given. Let us transfer one electron from one piece to another. For every 1000 atoms in a piece, what will be the Coulomb force between the two pieces after transfer of electrons if they are 10 centimeter apart? Beautiful. Such kind of problem we did already while we were discussing the concept of like electrification of a body, like how a body gets charged and all that. Right? You can also check with the playlist, or you can check in the description. I am going to give the link of that topic so that you can go and verify how to solve such problems, right? So now what is the main division of solving the problem? See, the problem appears to be so lengthy. Okay, any lengthy problem is usually given only to make you people scare. That is one point, and the other one is to waste your time. That's the motive of the examiner here. Right. So, any problem can be divided. If you find a lengthy problem, divide it into first parts. So, what is the best part, or what are the parts here that are very essential is, first of all, we have to find out number of atoms in 10 gram of copper. Right. So, weight of the copper is given to be 63.5 gram per mole. That means 1 mole that is 63.5 grams consists of, he already gave us Avogadro number of atoms, right? So that is 6 into 10 to the power of 23 atoms, right? So that means in 1 mole, that is in 63.5 grams, you have 6 into 10 power 23 atoms, which we call as Avogadro number of atoms present in a mole of a substance. Now the theme here is to find out for 10 grams. Right? So therefore that is for 63.5 grams, if you have this much, in 10 grams you will have 6 into 10 to the power of 23 divided by 63.5 into 10 grams. That means in each gram you have 6 into 10 power 23 by 63.5 into 10 grams. So this will be on simplification 9.45 into 10 power 22. Check by simplifying, right? I am giving you the concept, simplification part, you can check it out. Okay, right. So, is it visible? I feel like it is somewhat. Okay, now it's fine. Right, now the next one. So, now we know like how many atoms are there in each piece of copper. Okay, in each piece of copper we have 9.45 into 10 to the power of 22 atoms in each piece of copper. Now what is the problem? He said from every 1,000 atoms, one electron has to be transferred. Okay, so therefore, like 1 electron per 1,000 atoms, right? And the number of atoms here are, yes, 9.45 into 10 to the power of 22, right? So that means per one electron per the 1,000 atoms. And now how many atoms are there? These many. So therefore how many electrons are transferred? Very clear, 9.45 into 10 to the power of 9 electrons are transferred from one copper piece to the other copper piece. So what is happening here? As these many electrons are transferred, you will get that charge. The one which is giving out the electrons will get positive charge, and the one which is taking will get the negative charge. Thus what is happening? You have two charges of equal magnitude, Q1 and Q2, with opposite signs. Therefore the force is force of attraction. Clear? So therefore now our job is to find out how much charge transfer is taking place. You know that the charge Q1 is equal to Q2 is equal to NE, is it not? Number of electrons here are 9.45 into 10 to the power of 9 into charge of electron is 1.6 into 10 power minus 19 coulombs. So this much of charge is distributed, simple, right? And then when you solve this one, you will get it as 15.12 coulombs. This much of charge transfer is taking place. Or rather we say this much of charges are now formed on both the sheets with opposite signs. Therefore now the force is equal to, very good, 1 by 4 pi epsilon naught. So what is that value? 1 by 4 pi epsilon naught value is 9 into 10 to the power of 9. Right? So we need to simplify this. Therefore we are taking that value. 1 by 4 pi epsilon naught is 9 into 10 to the power of 9. Right? Into Q square, that is Q1 into Q2. Q1 is equal to Q2. Therefore it is Q square by D square. Now what is the distance of separation? How did he give? Is it if the electrons, if they are 10 centimeter apart? Can you see that they are 10 centimeter apart? Both the copper plates are placed 10 centimeter apart from each one. 10 centimeter in the sense 10 power minus 1 meter. So it is 10 power minus 1 whole square. Yes, 10 power minus 2. Right? So therefore on simplification, the whole thing you will be getting it as approximately equal to 2.06 into 10 to the power of 14 newtons. Right? So the simplification part you can check, but try to understand how the problem has to be divided. It seems to be very lengthy, but when you divide it into first part, what should we do? Second part, what is supposed to be done? Third part, what is supposed to be done? Then it will be very crystal clear. And if at all you get any problem of this kind, damn surely I can give you a guarantee that you will not lose marks from this. Or rather I can say that there are already plus 4 marks or plus 3 marks in your pocket if you find such a problem in the examination. Right? It's my challenge. Okay. So pause for a moment and then please note it down. I'll give you a minute. Right. Now another beautiful problem. Right, so here this is a vector application, okay? So the previous case is like that is from electrification concept, right? When you do that problem, automatically all the problems which come under that category you will able to solve it. Right. Now next one is vector category problem now. An alpha particle passes rapidly through the exact center of hydrogen molecule. It seems to be very beautiful to imagine also. Moving on a line perpendicular to the internuclear axis. Distance between the nuclei is B. Where on its path does the alpha particle experience the maximum force and how much is it? Right? Fantastic. So now here you have hydrogen molecule means 2H. Right? So 1H is here, 1H is here. Let us suppose that the intermolecular or like interatomic spacing is B or internuclear spacing is B. Right? Let us imagine it. Right. Now what is that? You take like internuclear axis, whatever is there, like an alpha particle is projected perpendicular to that axis in order to make it move towards the molecule. It is towards the molecule. That means alpha particle here is of 2e plus 2e, is not? The nucleus is of plus e. Here is also plus E. That means positive charge. So what do you see? Here is a positive charge. Right. Now here a positive charge trying to move towards two positive charges. What is happening? There will be a force of repulsion in this direction because of this nucleus. There is a force of repulsion because of this nucleus. Okay. And you can see very easily that since this is the one which is passing perpendicular to the axis and through the midpoint, right? Therefore, that means the distances are also same, right? What is this distance? Suppose if this is B, let it be B by 2 is equal to A for simplicity I am taking, and X is the distance, right? So that means this is X, this is A, therefore this is root of X square plus A square. Fantastic. This is also root of X square plus A square. That means the magnitude of the force acting on this is same because of both the atoms. Beautiful problem and very simple, right? In a very lucid manner, in a very smoothly you can solve the problem now. So two equal forces acting on a body, right, on a point or simultaneously, then the resultant is always given by 2f cos theta by 2, where theta being the angle between the two. Let us for simplicity imagine that this angle of separation is 2 theta. 2 theta by 2 is theta. So I got it here 2f cos theta. Right? Clear till now? No doubt here. Right. So now what is the magnitude of the force? 1 by 4 pi epsilon naught into Q1 into Q2. Q1 being 2E into Q2 being E by distance square. X square plus A square under root whole square. So this is the magnitude of the force. We know the magnitude of the force now. Now find out cos theta from this one. If this is theta, this is theta, this is x. Adjacent side hypotenuse is root of x square plus a square. So cos theta is equal to x by root of x square plus a square. Beautiful. We know now everything. Now what is the FR value? FR is equal to 2 into F being 1 by 4 pi epsilon naught 2e square, 2e into e, 2e square, root and square will get cancelled. So x square plus a square into cos theta. Cos theta is x by x square plus a square whole power 1 by 2 because it is a root. So where are we now? So 4e square by 4 pi epsilon naught. It's my habit of keeping 4 pi epsilon naught as it is. Depending on your option or your problem, you can cancel this. Right? I am leaving it just like that. Right? So now the remaining terms, that is x terms, I am going to write it like this. X square plus a square whole power 3 by 2, right? So this is what the force, resultant force is. Now we know what is the resultant force, which is acting on an alpha particle which is trying to penetrate through a hydrogen molecule. Fantastic. Now what is the problem? As he is asking where this force will be maximum. Where this force will be maximum? You know that for maximum, that is dF by dx is equal to 0. So therefore we need to differentiate this one. I am not talking about this. Why? Because this is constant. Anyhow will come out of the differential. And now this is what we are left with. So now therefore dF by dx, like suppose if you write it as like d by dx of x into x square plus a square whole power minus 3 by 2 UV method. Very simple. You can apply that one and you will be getting it as, right? So differentiating this is x, then now x square plus a square whole power minus 3 by 2 as it is. Differential of x is 1. Right, now minus 3 by 2 and like you will be getting it here as minus 3x square, 2 will get cancelled anyway, into x square, because 2x you will be getting x square plus a square. Did you get this one? It is x into here you will be getting minus 3 by 2 into the differential of this multiplied by 2x. That x and x is x square. 2 and 3 by 2 will get cancelled and minus 3x square. X square plus a square whole square whole power 3 by 2 minus 1 is minus 5 by 2 on adding the powers. Right. So this is the differential means after differentiation this is what you got it. Right. Now I wanted to find out at what x, that means at what distance this happens, is it not? Right. That means this has to be equated to 0. Right. Implies this is equal to 0. So now when you take x square plus a square whole power minus 3 by 2 as common, you will get 1 minus 3x square into x square plus a square whole power minus 1 is equal to 0, is it not? So now taking this into consideration, right? So therefore 3x square into, right, x square plus a square whole power minus 1, I will write it as x square plus a square in the denominator is equal to 1, yes or no? Beautiful, yes. So therefore 3x square is equal to x square plus a square implies x is equal to plus or minus a by root 2. Is it not? So why? Because it is 2x square is equal to a square, x square is equal to a square by 2, x is equal to a by root 2 and plus or minus. So thus yet x is equal to plus a by root 2 distance, right? And x is equal to minus a by root 2 distance. At both the distances the force will be maximum. But what is a? What is a? We took a to be this one, right? That means which is b by 2. So substituting x is equal to plus or minus b by 2 root 2, because a is b by 2. In the equation here you will get the maximum. I leave the problem here itself. Beautifully you can substitute and then simplify and find out the magnitude of F max. Not an issue. But now I am focusing on that part where x is maximum. Right? X is maximum at minus b by 2 and minus b by 2 root 2 and at x is equal to plus b by 2 root 2. Suppose if I take this as, right, right, when x is equal to 0 condition here, right, then this is 0, because on both sides you have hydrogen and here the alpha particle is, so they cancel each other, right, on either side. So therefore at x is equal to 0, that means exactly at the midpoint between, yes, hydrogens, right, then the force here is minimum 0. That means the force is here. That means on either side as you are moving on, right? So somewhere yet x is equal to plus b by 2 root 2 on positive x-axis, and yet minus b by 2 root 2, you will get maximum, f maximum, right? So this is very, very important. This analysis of this graph is important, or representing the problem in the form of the graph is important. Why? Because many times you will see a graph and then you need to solve, or after solving you need to identify the graph, right? So this is all for today. If you have not yet subscribed, please subscribe and share with your friends. Thank you for listening.